I want to go ahead and get started. I'll make myself smaller here a little bit with what is geology. And so we're talking about the study of the earth. Geology is often divided into physical geology and historical geology. Physical geology focuses on the earth materials such as rocks and minerals and the processes that create and affect them both at the surface and deep within the earth. Whereas historical geology, which is what this class is pretty much about, we are looking at how these materials and processes have operated over the vast history of Earth, focusing on the origin and evolution of our planet, its continents, oceans, atmosphere, and even life. So talking about a lot of different things here as we are kind of dividing physical from historical geology. So if you take Geology 110, Earth Science with a Lab, you're basically doing physical geology, but may have an introduction to geologic time or something more historical. In this course, though, we are focusing on historical geology. And so, we need to kind of go over, briefly the different rock types, and we'll do that for chapter 2 and some basic concepts like plate tectonics. But, we're mostly dealing with the history of life. History of our planet. We want to talk a little bit about what do geologists do, and I have an additional video in a little bit that talks about what is geology and also kind of gets into some of the different things geologists do. So it's not just rocks. So geology deals with 3 major concepts. First of all, and maybe something that you probably already have an idea about, is the extraction of pretty much everything we use in our day-to-day life. So if you use plastic, well, it's from petroleum. Almost all plastic is from oil. Any metal, all the metal that's in your cell phone, your car, your laptop, everything in your home, the plastic fibers in your carpet, all of that, it's all from the earth somewhere. Metals are removed from the earth as they are in this mine in South Africa. So geologists are dealing with the extraction of materials, and a lot of that also includes water. So water quality is all involved in geology too. Geologists also deal with the prediction and study of natural disasters. So things like earthquakes, tsunami, volcanoes, landslides, floods, even more what we would think about as more atmospheric issues like droughts and blizzards. Climate change, absolutely. These are all things that geologists deal with. So this actually, this was a really cool show. Now I forget what it's called. It just came out like last year. A documentary where they climbed down into, this is the Marum volcano in Vanuatu of, I believe, Indonesia. So very cool volcanic study to understand how do volcanoes work, and can we predict when they'll erupt, and so those are very important questions for geologists to deal with. And then geologists also, we'll see that in this class and almost every class I teach, the boundary between geology and biology is pretty fine sometimes. So geologists also deal with climate, so trying to understand modern anthropogenic or human-induced climate fluctuations and compare those to climate changes of the past. Climate has always changed throughout Earth history. Well, what kind of things have influenced those climate changes throughout Earth history? Can that help us to understand what changes climate today? How humans play a role in it, what's going to happen in the future. So in this picture, we have a couple geologists who are drilling into an old coral head to get samples that tell us about changing ocean chemistry and climate. So yeah, definitely getting into some biology here as well. So one of the things that I get really into, and some of you guys probably know this already, is understanding some really big concepts. So scientists, one of the things that scientists do is they look for patterns. So geologists do too. So scientists look for patterns and apparent coincidences and try to explain them. So for example, from studying geologic maps, we can see that the mountains of Scotland, as here pictured on the Isle of Skye in Western Scotland, contain identical rocks to some mountains in Morocco, Greenland, Norway, Eastern Canada, and even our own Appalachians, including the Smoky Mountains of Tennessee. As we'll see, it was this link between these distant places, as well as many other coincidences that allow geologists to begin to explore the biggest question and formulate the most important theory of all geology, and that's going to be plate tectonics. So here's a kind of a little sample of what one of the major concepts we'll be dealing with is the formation of the Appalachian Mountains. And the Appalachian Mountains are just one piece, one large piece, but one piece of something called the Central Pangaean Mountains. So when all the continents came together and collided to form Pangaea, we have mountain building going on when, like as happens today when continents collide. We can see it happening today in the Himalayas of India and Nepal and Tibet. But it has happened before, and then as the mountain range splits apart and divides, well, now you have bits and pieces of those same mountains that formed at the same time from the same process in many different parts of the world. So geologists had seen that there are a lot of similarities between these rocks and mountains in these very different parts of the world, and we're like, how could that happen? So plate tectonics is our major theory that we're dealing with here in this course. And how did that idea develop? So this is one of the things that kind of got the wheels turning. So that's one of the big concepts we'll get into. So as we are getting into patterns and processes, we're looking at science. So and that's what we're going to focus on for the next section.